9 a.m. Vancouver time. So, welcome everybody. Thank you for spending the next hour with us here. We'll introducing a new product for CGIS and a new innovative way of looking at some maybe older technologies in valves. So, with me today is Chris Cannell. He has been with Oxford Flow for 8 years. Before that, Chris was working on getting his PhD on high-speed aerodynamics, designing rockets and high-speed aircrafts, and specializing in hypersonic flows, which gave him a lot of great experience and technology to bring into the design of this valve. So, you can go to the next slide there, please, Chris. One of the things that we really were interested in with working with Oxford Flow is adding to our repertoire of valves. I think if you look at our vision, a world without valve problems, one of the things that we recognize is that there's no one perfect valve that will fit every application, and you really need to find the right product to solve a multitude of different problems that we face in the valve world. And in working with Oxford Flow, we've seen some really cool, innovative ways of approaching some of those old problems. So we'll look at that today. Next slide, just some housekeeping here. Sorry, just again a little bit about CGIS before we get into Oxford. For those that aren't familiar with CGIS is a parent company that has been in business now for 45 years, solving some of the world's toughest valve problems. In order to do that, we've also brought in a number of partners that help us around the globe. DHB, our partner out of Quebec, DSS Valves International, our guided shear gate valve, flow control out of Australia. Nova Hydromet is one of our very specialized divisions that look after specialized valves for the Hydromet world, and then our sister company, Custom Gaskets, out here out of Vancouver as well. And next slide now for some housekeeping. So one of the things we do really like with these webinars is the back and forth. So if you do have questions throughout, please pop that into the Q&A box that you'll find at the bottom of your Zoom window, and we'll either try to answer them in the moment, or if we can't get to them right then, we will make sure that we look back at the end here and follow up with those answers. And then after the webinar, Sam will be creating a recording and be able to send that out, as well as follow up with any other potential opportunities that you see. So with that, I will hand this over to Dr. Chris Cannell.
Okay, great. Thanks, Braden, and hi, good morning, everyone. So yeah, I'm Dr. Chris Cannell. I'm with Oxford Flow. I'm part of our Americas group based out of Houston. I'll be taking you through some interesting new technology today and a bit of background on our company and how we're breaking into the market. So this is just a general overview of the key technologies that we do. So as Braden said, feel free to ping some questions in the chat as you have them, and yeah, I'll try and answer them. A bit on Oxford Flow, so just as we sort of get into it. So the company's just turned 10 years old. Originally, we're a spin out from the University of Oxford in the UK. Basically, a professor within the turbo machinery and jet engine research lab was getting very fed up with his existing valves he was using. They weren't accurate enough, they weren't reliable enough, they weren't repeatable enough, they just were a hassle to use. After many headaches dealing with the traditional valve manufacturers, he got so fed up that he basically said, screw this, I'm designing my own new style of valve. Then him and his team of graduate student labor designed some new valves. And yeah, when we were looking at the valve industry, no one had really brought a truly new design to market in decades. So we founded Oxford Flow to commercialize that technology and just take a bit of a fresh look at valves and see whether at a fundamental design level we can come up with some better designs that really solve some customer pain points. Fast forward to more recently, Oxford Flow's got quite strong industry backing. So BP are one of our major investors, along with a lot of the North American midstream companies, all of which are in various stages of rolling out our technology for various reasons around emissions reduction and improved reliability and yeah, just generally improving their operations. Oxford Flow is a global organisation, so most of the heavy lifting is out of the UK. So that's where the head office is. That's where all the design, manufacturing, quality assurance, all of that good stuff happens in the UK. I'm part of our Americas group based in Houston, Texas, that covers North, South, Central America. And then we appoint sort of regional distributors and partners to help us along the way. We also go across a lot of different market sectors as well. My day-to-day is super varied, from talking to water networks, gas utilities, chemicals plants, offshore platforms, you name it. A lot of different market sectors are having issues with the valves they're using. And as I'll get into, the technology that we have has a few different angles on it that can help address a number of different problems. So yeah, before I get into the details of the product, again, all of our stuff is basically designed from a blank sheet of paper. It's not a kind of knockoff of this or a slight tweak on that. It's a fundamentally different design that I'll be taking you through. And really, one of the core design principles behind it is simplicity. One of our main sort of design pillars is less things there are going on in it, less things there are to go wrong. So hopefully that you'll sort of see that as I take you through the products, that we identify the main part that's normally failing and seek to just design that out. So yeah, so I'll be taking you through our main product lines today. So we've got a range of pilot operated pressure regulating valves that I'll be taking you through, both for liquid and for gas applications. We use those widely across the utility sectors at the moment. And then I'll also be taking you through our range of actuated valves, either for isolation or for control. I'll start off with the actuated valves, because that one's my favorite. So yeah, a bit of background. So obviously there's a lot of talk in the industry around emissions at the moment. Valves are a big contributor when it comes to emissions. A lot of studies put it around 60% of future emissions come from leaking valves. The interesting thing for us is when you sort of zoom in on your valve, unsurprisingly, most of that leakage comes from the stem packing arrangement. So the dynamic piece that's sliding through the valve, over time, that stem packing will wear out, cause leakage and emissions to atmosphere. Everyone else is kind of just putting in slightly better stem packing, your live loaded packing, your low E packing, which will last a little bit longer, but will still eventually, with a certain number of cycles, will wear out, will fail, will cause issues. So we've taken a bit of a different approach when looking at this and said, well, if the stem and the stem packing are causing all the issues, why don't we design a valve that doesn't have that stem and stem packing arrangement? And that's essentially what we've done with our ES series valve. So on this style of design, essentially what we've done is integrate the valve actuator within the body, the main body of the valve. So now, rather than a mechanical drivetrain coming in and turning the ball, sliding the plug, sliding the gate, in place of that mechanical system, it's a direct hydraulic drive. So the yellow ports that you see here are hydraulic feed inputs. And by filling and draining internal hydraulic chambers, you can move the plug or the control cage between open and closed. It'll become a bit clearer on the next slide when I show one actually moving. But yeah, direct hydraulic drive, that actuator is now fully embedded within the valve body, so there's no sort of mechanical top works pushing a stem. And when it comes to emissions, that main sort of source of all of that leakage, the stem and the stem packing, is not present on this design. So yeah, just to show an actual snip of the image, a snip of the animation moving there. So you see this one's a double acting style arrangement. So you're filling one side, draining the other, and that's moving that plug or cage between open and closed. So yeah, that one, it's a new way of doing it. So it's an axial flow style design as well. You may or may not have seen axial flow style valves before. So basically the flow is coming in from the left around a central core and then is being throttled on the outlet of the valve. So if I go back to this one, you can sort of see in the animation. So the flow's coming in from the left here around this central piece and then out at the end, and you'd be doing a throttling or kind of modulating control. right at the outlet of the valve. There's a few benefits to this style of valve arrangement. One, you get much higher flow capacities. So because you're not, if you think about, say, your conventional globe style valve, the flow's coming in, turning again, it induces a lot of pressure drop, reduces your capacity. This style of valve isn't really turning the flow much at all as it goes through. So that enables us to have a much higher flow capacity. So you can potentially, when you're designing your systems, downsize what valve you need for it. So if you needed a 10-inch or a 12-inch globe, you could use an 8-inch or maybe even a 6-inch axial flow style valve. In terms of operational benefits as well, if you've got quite a severe application, so say you've got debris or your pressure drop is inducing cavitation bubble formation, all of that throttling is happening right at the outlet of the valve. So say if you've got sand particulates or anything like that, they won't really be gaining any velocity or anything in the body of the valve. You'll be doing your throttling at the outlet, and all of your kind of high velocity jets you'll be directing into the center of the downstream pipe. Same with your cavitation bubbles. All of those implosions will be happening center of the downstream pipe. Again, compare that to, say, a globe style arrangement. You're turning the flow in through that inlet bowl. All of that erosion damage, all of that cavitation implosions will be happening right in the center of the valve, damaging the body and potentially damaging the seat and the plug and the cage. So all of that obviously reducing the life, sort of the operational life of those valves. So there's a few other benefits to the style of actuation beyond just, I've already spoken to emissions. In addition to that, and like I say, different, depending on the use case and the application, different people sort of find different parts of this more interesting for them. Obviously, you see a more traditional valve here on the left, large external actuation set, especially if we're talking about pneumatic actuators. As you go up in size and up in pressure class, those pneumatic sets get bigger and bigger and bigger. We don't need all of that top works. We're not trying to drive that mechanical system. So in place of your conventional actuator, we supply the valve with an electrohydraulic power pack, basically a small hydraulic pump set that can either sit on the valve or somewhere nearby to the valve. And the nice thing is that doesn't really scale much at all with valve size, because those chambers that we're driving, it takes a very modest amount of hydraulic fluid to move in. On the 4-inch version of the valve, it's about 100 milliliters of hydraulic fluid. On the 20-inch, it's still less than a liter. And to give you some context, that the pack that you see there, a Rexa setup, that's about like a 2-3 liter tank on it. So yeah, it really doesn't scale up in the same way as especially those pneumatic actuators. So if size and weight are a concern for the applications that you're going into, like often talking to people who are dealing with offshore operations or congested plant settings, yeah, saving that space can be a huge benefit. In terms of reliability as well, so there are fewer mechanical parts in our arrangement. Basically, all of the mechanical linkages that you would normally see in the actuator and drivetrain don't exist in this product. It's not, you're not driving it mechanically in the same way. So if you're dealing with a particularly high cycle application with a conventional drivetrain, you may be worried about those linkages rubbing and wearing out over time. In our arrangement, it's just that piston moving back and forth, so it just doesn't wear down in the same way. Similarly, if we're talking about an emergency shutdown valve application, so the valve spends 99% of its life fully open, and then when it comes to close it, is it going to close? Is it going to seize up? Are you going to have to over torque the valve stem and break something? Again, our product doesn't have those mechanical risk components. Yeah, for us, it's if you need to overpressure the hydraulics slightly to overcome some stiction, no problem. It's not going to cause any damage in the same way that over torquing a valve stem would. So yeah, there's a few different angles on this, and it's always interesting to explore where the customer pain points are and how this can address it. We've got different styles of the arrangement as well. So I showed the double acting style, so a bit more suited to say if you want a fail state of fail in place. We also offer single acting versions. So you see the cutaways here. There's only one hydraulic chamber, and we've got a spring return mechanism in the center of the valve. So this is a bit more suited if this one in particular, fail closed. We can also reconfigure it for fail open as well. So depending on the application at hand, we can sort of chop and change the configuration depending on what fail state you require in particular. And then in terms of that hydraulic set, so you see that actually that's a different one that I showed on the previous slide, and that's because we'll supply the whole assembly through our partners, but we actually buy in those hydraulic sets and controllers third party from actuator manufacturers, because really the innovation for us is in the valve. Good hydraulic sets have been on the market for years. So basically, we're going to these actuator manufacturers and buying 2/3 of their normal electro-hydraulic actuator set. Basically, instead of plugging into an actuator, we're plugging it straight into the valve. So the system that you see mounted here is already tried and tested, known technology that's been on the market for many years. And we're working with companies like Rexer and Rotork and Rotex, and our strategy is to qualify a number of these companies, and then we can choose what's best for the application, or if there's a customer end user preference. But one of the other nice things is that I mentioned that those packs don't really scale. It also means they're very low power. So if you've got a remote location that you're operating the valves in, this is a very low power way to achieve a high pressure class valve. For example, this system here, it's less than 200 watts to run the thing. So you could conceivably run it from a solar panel and battery setup. This can be used either as an isolation valve or as a control valve. So the images I've shown so far have been with basic kind of plug trims on there, but we've got a whole library of cages, contoured plugs that we can choose from depending on what control characteristic you want out of the valve. We would be looking at that as we're basically reviewing the specification and running the sizing. But again, one of the good things about axial flow is your base level flow capacities are very high. So if you want, say, a multi-stage trim set or something like that, we've got more flow capacity to work with, so it can fit in more stages and you can use a smaller valve.
Chris, just to interrupt you, a couple of questions came in that would be pertinent. One, you guys make up to class 4,500?
So class 2,500 at the moment.
Okay. And then just based on some costing, how do you sort of compete, or how do you compare to some of the competition on maybe some larger valves, like an 8-inch valve? I guess it really depends, but
sure. I mean, I'd need to review a specification, to be honest. That's the best way for us to sort of give a true price. In terms of this isn't a commodity product. I'll be quite upfront about this. It's an engineered valve. If we're trying to match, say, a carbon steel ball valve, then that's not us. So we're looking at the sort of more severe service valve end of the market. At the moment, this is a build to order style product. Typical deliveries in sort of 24 to 28 weeks, depending on the specification that we receive. If you've got an application in mind, I'd be more than happy to review it and give some sort of budgetary numbers around it, based on the specification.
And I think too, one of the things that we've seen just with some of the pricing, if depending on the actuation that's required from the standard valve, I think that can have a massive impact on it. Like if you look at some of the electrohydraulics on the market, some of the fail-safe units for conventional isolation control valves, that can have a big impact. Whereas the integrated actuation package with your valve can have a big benefit to the overall costing, I think. But yeah, for sure. Thanks.
Found the proper box to see where the questions are now. So all good.
I was that's all good.
On the spot.
Yeah.
Our applications limited to those where potential of hydraulic fluid into the process is not a concern. Obviously leakage of hydraulic fluid is a risk on this, and with any sealing interface, there's always a risk of leakage. We've built in levels of redundancy into the sealing arrangement, such that basically you've got an outer layer of sealing, and then you would have to go through that into that redundant layer of sealing for there to be actual leakage of hydraulic fluid into the process. And what we have through the hydraulic system, we can actually do a level of predictive maintenance and health monitoring on those seals by basically looking at the hydraulic pressure it takes to move the valve, monitoring that over the lifetime. If it suddenly takes 100 more psi to move it than it did yesterday, that's an indication that your sealing health is starting to degrade. So you can plan and schedule your maintenance of this thing. Because obviously the enemy is unplanned maintenance. So yeah, but we've often worked with manufacturers. Well, so we're working with a number of facilities where we're quite flexible on specifying what the hydraulic fluid is. So, for example, I'm dealing with a chemicals plant at the minute where we're looking at what grade they would prefer because it's non-reactive with the chemical that they're using, and there's a compressor upstream that's already leaking a load of that oil into the process anyway. Worth noting as well, because of those small volumes in the system, even if it's like a litre, 2 litres of fluid in the total closed loop system, so there's not a lot on. Yeah, there's not a lot to go into the line, but obviously some applications are high purity, supercritical, so obviously we're mindful of that. Let me just get through to, so in terms of the general range and specification, so 2-inch through to 24-inch, class 150 through to class 2500, minus 46 through to plus 150C at the moment. So I saw the question in the chat around 725C. So unfortunately, that's a bit of out of our ballpark at the moment. We have got development initiatives around increasing our upper temperature limit. And I'll explain what the limiting factor is in a second, because it leads nicely into the second question, which is how do we get position feedback? So I will skip back quickly to the image where it's moving. So having removed the conventional valve stem arrangement, normally you'd look at how much that has slid or rotated to look at your valve position. Obviously, we don't have that anymore. So one of the enabling technologies behind this is a new method of position indication. So what we've actually done is within the moving assembly of the valve, so actually in the central shaft, we embedded a magnet. And then as the valve moves back and forth, that magnet moves along with that assembly. Then in a blind hole in the valve body, so not wetted, not pressurized, we've got a Hall effect sensor. So as the magnet strokes past, that Hall effect sensor will pick up a linear trend and output basically valve position as a 4 to 20 milliamp feedback signal. So yeah, in terms of how you're interacting with this and feedback that you'll receive, it would look the same as any other valve on the DCS. Because that sensor, the PCB for that sensor is within the valve body, the limit on our sort of CSA, hazardous area approval, is basically up around 140, 150C, because that's the limit of PCB electronics. So yeah, that's how we measure position, and yeah, that's why we can't do 725 just yet, but we have got active development initiatives looking into getting beyond where we're at to get into, especially the refineries market. They've got a lot of high temperature stuff that we want to get into. In high operation pressures, is there any danger of mitigation of hydraulic oil to the process? Yes, I mean, as I said earlier, there's always going to be a risk. It's about how you mitigate that risk and sort of design around it and against it. So looking at what the process conditions are, is there debris in the line? Do we need to put extra levels of sort of scrapers or filtration to protect the seals? And then, as I mentioned, there's a level of redundancy in the sealing, along with that kind of predictive health monitoring of the seals and predictive maintenance from the hydraulic set, monitoring what pressure it's taking to move it over time. In terms of lockout, tagout, that's basically built into the hydraulics set. So all of that can be done on that package. And there are manual overrides depends on which hydraulic set we choose and what options there are. But that that's all got the kind of lockout, tagout capability built into it. In terms of isolation valve, we can So we can use this for we can use this full on-off isolation. The shutoff class you get will depend on what seal configuration we choose. We've got soft seat bubble tie class 6 shutoff, or we've got metal to metal seating class 4 or class 5. Obviously, which one we're choosing kind of depends on the application we're going into. You wouldn't really recommend a soft seated valve for a very severe dirty service. So yeah, kind of in line with what you would expect from other isolation valves. Right, I'll get back to, so in terms of general specification, as I mentioned, these are the current sizes and pressure classes. Different options for soft and metal seats, as I just said, and a whole library of trim sets to choose from. So yeah, depending on basically what's needed for the application. And in terms of face-to-face and the gap we're fitting into, so typically we're either building these to the ANSI globe valve face-to-face or the ANSI, the ASME ball valve face-to-face or the ANSI globe valve face-to-face. So kind of our two standard configurations. As I say, this is a build-to-order product at the moment. So yeah, if you need a custom length, we can do a custom length. I would recommend against putting weird length valves into your systems, but yeah, it all depends on what the facility is doing. So yeah, as I mentioned, we've got a variety of hydraulics packs to choose from. So yeah, really depends on the application and whether there's a brand preference. And yeah, each of these have kind of got their different bells and whistles depending on what you're getting into. In terms of testing and certification, which leads me nicely onto the question I just got, is it suitable for abrasive slurries? So one of the certification programs we ran this through was the API grade sand slurry testing program. So that's basically normally the test that you perform on wellhead safety valves to prove their durability in service. So we put the valves through that. That's basically an indication of how durable those sealing configurations are. So it passed that with flying colours. No through seat leakage, no external leakage. So we're certified to that. In terms of other certifications, so it's we did some initial functional safety and reliability analysis on the product. Obviously, it's still relatively new to the market, so it's not got years of failure rate data behind it. But through a program of in-house cyclic testing and from sort of data that we've got from the pieces that we're buying in, we did an initial SIL style study and basically a testing program that would bring that total assembly to SIL 2 levels of reliability, so SIL 2 capable to go into those safety instrumented systems. Also, I mean, I've spoken a lot about emissions. We've obviously backed that up by actually doing the emissions testing certification. So that's the ISO 15848 emissions testing program. So what that is you fill the valve with high pressure helium and you cycle the valve, you cycle the temperature, and you're sniffing for helium leaks. And there's different category ratings, A, B, C, D, depending on what emissions they measure. So we scored Class A, unsurprisingly, no stem packing to leak. And actually, in terms of the amount of emissions measured, we're orders of magnitude better than Class A. So yeah, very well positioned for the future as kind of emissions controls only get tighter. Also fire rated as well, so 6FA 607 fire safe product. So yeah, again, depends on what's needed for this facility, but it gave us one of the cooler pictures from the testing. So yeah. This is more for, we'll send around a recording and send around the slides as well, but this is sort of summarizing a lot of the points I've been talking about and helps me remind anything that I've forgotten. So yeah, obviously I've spoken a lot about the emissions benefits, removing that stem packing arrangement and really truly addressing the emissions at the source. When it comes to performance as well, so I mentioned about the maximizing your flow capacity, potentially using a smaller valve for the same job. Some of the other benefits of axial flow is if you've got, say, need low shear, if you've got produced water, you're trying to keep oil droplets together, not disrupt the flow too much. It's a very low shear arrangement because of that axial flow nature. Also very fast response as well, if required for the application. So say, because that hydraulic volume is so small to drive it, we can potentially move this thing in fractions of a second. So looking at applications like compressor anti-surge, where you want to move the valve very quickly but with high accuracy. So you've got kind of the benefit of a high-speed valve, but the precision of a hydraulic arrangement with this style of products. Size and weight, yeah, that's basically to the tune of how big would the conventional actuator have been. So that's kind of most of the benefits there. But also a level of flexibility as well, because obviously with a conventional actuator, that has to be mounted on top of the valve. There's not a whole lot of design flexibility there. With our hydraulic set, you can mount that completely remotely from the valve if you want to. If the valve is in an awkward to reach location, a hazardous area, or just a generally difficult spot to work on, you can mount the hydraulics on the wall around the corner at ground level, whatever you need, and run some tubing. So that's a level of flexibility there that, yeah, you wouldn't have on a normal valve actuator. And reliability as well. And obviously, as I said before, that's kind of down to the simplicity of the product. So, yeah, just fewer mechanical parts to wear out, to fail in this design. So has the valve been tested in a vacuum environment? We've not done too much on the vacuum service yet. I've reviewed some inquiries around it. There's no inherent reason why it shouldn't be good in a vacuum. It's more just looking at the valve that is sort of in place already and what benefits this would bring over that. So more than happy to review vacuum applications. In terms of corrosive environments, that kind of comes down to material specifications. So, yeah, obviously we can specify this in whatever material grades required for the application. So whether it's NACE rated, whether it's something more exotic, and then looking at the sealing materials as well. All of that would be part of the initial specification and sizing process of what we would use, and especially engaging with you guys as the end users. What have you tried before that didn't work? Because we want to make sure that we're definitely improving upon, yeah, what you previously had in. Who's already using it? So this one is relatively new to the market, only released commercially maybe 2 years ago. But there are some big names that are starting to use it. So Kinder Morgan recently set up some of these on new carbon capture facility in Colorado. I've got some pictures of that on the next slide. So that's for some supercritical CO2 blowdown control applications. So they, yeah, are using a few of the valves for that on the compressor package. Oxy have got some of these out in West Texas. It was really the low power benefits that they quite liked. So yeah, quite remote location service. So the potential to use these from a solar panel setup, as I mentioned before. Petros, some folks in Malaysia, so they're using for emergency shutdown use. Again, as I mentioned before, the worry about emergency shutdown valves is they sit in one position for a really long time, and yeah, making sure that they operate when they actually need to do the emergency shutdown. ADNOC have deployed a number of these in their offshore operations in the Middle East, so for flow condensate control. Yeah, rolling out a number of initial trial units to kind of validate the technology and kind of move it along in maturity there. Harbour Energy, so they're a North Sea, UK oil and gas operator. Again, emergency shutdown use, kind of similar story to the Malaysia one. And then BP are in a process of rolling this out across one of their refineries in the US for kind of loading, unloading valves. So yeah, and BP liked the product so much they invested in the company at the same time. So that was a sort of show of confidence. Yeah, another question on, so given the closure force is provided by a spring, how good is the seal in reverse flow conditions or when the downstream is higher than the upstream? So let me skip back to so this is referring to the single acting configuration here that I mentioned. So this is inherently fail-safe closed. So the spring does provide some closing force. Actually, most of the force on this comes because it's an unbalanced arrangement. So if you look at this design here, so flow's coming in from the left, red is the upstream fluid, blue is the downstream fluid, yellow is the hydraulic feed. So you can actually see that the blue, so the downstream, can get in through these balancing holes, and now also get in through here and don't know whether you can see my mouse or not. So yeah, can get in through that rear piston, and it's actually an unbalanced system. So when there's any pressure in the line, that valve is trying to shut itself. So the spring provided a little bit of force, mainly for those situations where there's not much or any pressure in the line, but most of that shutoff is coming from the actual pressure of the line. And the way that, depends what seat arrangement we use, but for this one in particular, this is the soft seat arrangement. It's actually not a thrust loaded seat. It's a positional based seat. So once the piston has moved into a certain position, that radial seal will just seal up, and that's good in either direction. So yeah, it's not based on a certain loading force. So you could put this on complete kind of reverse differential and it'd be fine. Oh, forward. Yeah, so those are just some pictures of the ones out in Colorado that I mentioned. So the blowdown valves on a new facility that they're just bringing online. And just a few examples of where Equinor, the Norwegian oil and gas operator, also used them. Basically, for a limited time, they deployed them in their Kårstø facility in Norway, where they've got an area where they try out new technology and basically try and break it. So they put the valves through a number of different applications, and then after a period of a few months, took the valves out, did some functional testing, did some inspection, and yeah, that formed part of our kind of qualification process. So yeah, it all passed with flying colours, and they were very happy. Cool. So the next bit of the presentation is on the regulators. I'm just going to take a quick pause if there's any other questions people want to ask about the actuated valve products before I get into the regulators. Nope.
Maybe just quickly, I know it came up on a previous
Yeah.
email with another client, the CRN wise, just for the Canadian content
Yes.
here, everything
Yeah.
that's
So all of this is CRN approved for all provinces. So I can share all of that documentation.
perfect.
Yeah. Thanks for reminding me. Cool. So yeah, regulators. So yeah, taking through our actuated valve products. Now I'm going to take you through our range of pilot operated pressure regulators. This is kind of the technology that kicks off the company. A lot more years in service, a lot more units in the field. This one's much more mature. So I'll start off, I'll sort of talk a little bit about conventional regulators. So this is your normal style regulator. You see right in the center of the valve, there's a big main body diaphragm. So normally that's what's flexing and moving to control the pressure in the system. They're pilot operated. So the pilot would be sensing the pressure upstream, sensing the pressure downstream, and providing a loading pressure behind that big diaphragm that flexes and moves and, as I say, regulates the pressure. This is a very old design concept. Before those big diaphragms were rubber, they were leather. It's not really kind of evolved over the years. So, and when we speak with end users, most of the headaches and pain points are something to do with the big diaphragm in the middle of the valve, whether it's tearing, whether it's bursting, whether it's leading to inaccurate control. Having a large soft good in the center of your valve just makes it vulnerable. So when we were looking at that, again, people are putting in better diaphragms, better materials, all of this. We took a bit of a different angle on it and said, well, does it need a diaphragm? Let's do it differently. So yeah, that was what we did. So in place of the diaphragm, we actually, in the center of our valve, there's a piston-based design. So still axial flow, because we like axial flow. But now, yeah, it's a solid piston that's controlling the pressure rather than that large soft element. And yeah, when you do an exploded view of that, there's not a whole lot going on. The analogy I like to use is imagine the pistons in your car engine, rated for many hundreds of thousands of cycles. The sealing arrangement on this is very similar, so very durable and robust. It's still pilot operated, so we have our own range of pilot valves for different pressure ranges. If you want inches of water column or something higher in the range, we've got different pilots and different springs to choose. And then now that's loading and unloading a very small volume behind the central piston rather than a large volume behind a big diaphragm. And that's really the key difference here, and the benefits that that brings. Um, one being the durability. So having a solid piston is a lot more durable than having a large rubber element. Size and weight as well. It doesn't need that large body to actually house the big diaphragm anymore. So we can package our valves much smaller, much lighter. So especially when we're dealing with skid fabricators who are trying to shrink their things as much as possible, that can be a benefit. Yeah, and it's also got a wide range of stability as well. So often you see on the regulator, on traditional regulators, they may have a very narrow window of stability, and you'll fit different trims, different cages to move that stability around. Our valve is completely stable across its entire operating range. So yeah, if you're operating this very near closed, it'll still operate with complete stability. So the rest of it is basically the different configurations that we've got for the different markets. As I mentioned, we've got liquid versions, we've got gas versions. So yeah, I'll just take you through the different configurations that we do. One of the initial industries to pick this up was the municipal water sector. They were quite willing to try something new. Obviously, the risk is a bit lower in a water network than with hydrocarbon service. So yeah, they were quite open to sort of trying things out and playing with it. For that market, because of the low pressures, we actually do a version of this valve that's completely made out of a polymer. So whole plastic design, NSF approved, but super lightweight. I can pick up an 8-inch valve by hand. And yeah, I'd bring them into meetings. People would think I'm bringing a model in, and it's a real thing. So yeah, that one's 2-inch through 12-inch, up to about 16 bar rating. And this one we got wide deployment across mainly those utilities sectors. I'll say a bit in the commercial building space as well. We can configure these regulators either for pressure reducing service, so controlling the downstream, back pressure, controlling the upstream, or we can change it around and do it for things like tank level control. So replacing the pilot valve with say a solenoid to monitor a tank level. Again, an axial flow style arrangement, so a lot of the same benefits as the previous product I was taking through. You can see here we've got a kind of cutaway of that traditional globe style arrangement. So you can see flows coming in from the left, and basically at that kind of turning point, that vortex in the middle, that's just where your diaphragm would be. So if it's got particulates or debris in there, that's tearing and scraping on that big rubber sheet. So yeah, compare that to our style of design. We're just throttling with that piston, so it's inherently a lot more robust. Other versions of the liquid one, so obviously plastic one's great for kind of municipal water service. As we get into kind of other liquid services, we've got a version that's all 316 stainless steel. So I use that a lot for LPG applications, kind of back pressure control on pumping skids. Another version of the plastic one we've got is for mobile water treatment packages. So because that plastic one's so lightweight, we've actually made a portable version of it where we put it in a set of handles and hose adapters. And companies that offer mobile water treatment solutions can pick these up and throw it in the back of the truck very easily, which you wouldn't normally be able to do that with a 4-inch, 6-inch valve. I also sell them to a few fire departments as well, which is an interesting one. So on a few fire trucks. Obviously, as the valve gets bigger, higher pressure rated, we've got kind of a heavier duty version. So this is a fabricated version. So this one's got flanges rather than that wafer arrangement. And this one can scale up to much larger sizes. So the largest we've provided so far has been a 20-inch version of it for back pressure control on with an oil and gas operator in Argentina. But the biggest designs we've done have been, I think, up to about 30-inch on this. So yeah, much more scalable. So yeah, if you need a big regulator, this can be a good option. On the gas side of things, so we've got a couple of options on gas. Again, similar range of applications. So pressure reducing, back pressure, and we can also do things like tank blanketing as well by utilizing different styles of pilot valve. The first style is our wafer configuration. So this one, full 316 stainless steel design. So yeah, this one, we use this a lot for natural gas pressure control. currently, but rated for any sort of relatively clean gas service. 2-inch through 8-inch. Nice thing about a wafer is the whole body is class 600 rated, but it can be installed in 150, 300, or 600 flanges, so quite flexible there, depending on what system it's going into. All of these valves have a soft seat, so bubble tight shut off on the regulator as well, so that piston is coming up against a soft seat. This one we've basically shrunk down to as small as we can get it, and it actually fits the same face-to-face as a capacitor regulator that you may see called the American meters valve. So yeah, this one can drop into that same gap. Some end users prefer a more traditional looking valve, so we also do an arrangement that fits into a more standard globe body style. So carbon steel globe body with stainless steel cartridge. So this one's top entry serviceable and obviously conforms to the standard globe face-to-face arrangement. And it really depends on the preference of the end user. A lot of the benefits are the same in terms of the reliability benefits and using that piston style. The benefits are the same, it's just a different form factor, a different package for it. Again, 2-inch through 8-inch, 150 through to 600. Obviously on this one being a globe, the bodies will be flange specific in terms of 150, 300, or 600. Yeah. Again, more for you guys to read through when I send it around, but in terms of the key value proposition to this, reliability, again, we've removed the main part that was typically failing, that main body diaphragm. Depends what sort of application we're sending into, but especially the relatively clean utilities service, our recommended servicing interval for this is 10 years. And even then, it takes 15 minutes to change the O-rings and PTFE wear strips on this. It's not a big job at all. In terms of resilience, again, a stainless steel piston is going to be a lot more resilient than a big rubber diaphragm. In terms of performance benefits, we get much higher levels of pressure control accuracy out of this style of controlling pressure. And that's basically because a piston moving on a single shaft is going to be able to move more accurately than a sort of 3D flexing, deforming sheet diaphragm. And all of that resulting in various cost benefits. So again, depends on where you're putting it in, but it could be an OPEX benefit of not needing low flow regulators. It could be an OPEX benefit of not having to overhaul your regulators as much anymore, really extending those servicing intervals. Or it could be a CAPEX benefit of not needing a low flow regulator and only putting in the high flow regulator. So yeah, there's a few different angles on this. And just to sort of finish up, just some pictures of some real valves. I've shown some nice renders and things like that. So yeah, in terms of what we've got in service, I like to show these pictures on the right. So on this yellow tubing, so this is a pressure control station in Scotland. You see there a common competitor that we're replacing in the UK market. So a large direct acting regulator there. And you see ours just next to it. Both of those are 4-inch class 600 valves. One of them I can pick up, one of them I can't. So yeah, the difference in size and weight it's not a bit of a difference, it's quite dramatic. Often you'll see our regulators configured in what's called a worker monitor or an active monitor configuration. So you'll see a pair of them, basically with one regulator doing all the pressure control, doing the work. And then you'll see another regulator, normally upstream of it, as the monitor, basically with set points slightly higher, and that'll take over the pressure control if there's a problem. Equally, you can configure them for things like 2-stage drops, sort of 2-stage cuts. All of that is different ways to configure the pilot valve arrangement and the control setup. These are the LPG valves in Mexico. So these are on LPG refilling stations. So as acting as back pressure control on the pumping system. They were previously having issues with freezing on the regulators and the diaphragms basically kind of getting brittle and breaking. Obviously, a stainless steel piston can't do that, so we could help them address those problems. Gas compression is also a good market for us. So fuel gas regulators. So say going into the large high horsepower natural gas engines, often controlling the pressure going into those sets, and often there are a few other regulators on those kind of packaging skids there. For those end users, we've also pre-packaged the valve sometimes in threaded connections. That's easy. That's kind of configuration we can do, along with that kind of extra anti-vibration support as well. So obviously those engines are trying to shake themselves to pieces. So yeah, and we've got a number of those deployed out in West Texas, and obviously that's not the cleanest of gas going through it. So yeah, again, proves the durability of the regulator setup. Hydrogen. So obviously the hydrogen market kind of comes and goes. It depends on incentives and all of that sort of thing. We're doing a bit on it in UK and Europe. We're on a number of pilot projects. Our regulator is basically ready for 100% hydrogen. So normally what you'd worry about with a hydrogen service, you'd be worried about leakage of the hydrogen through the big diaphragm, kind of permeation of the hydrogen molecules. Our stainless steel piston doesn't prevent that same leakage surface area. So yeah, potentially good for hydrogen applications. It's exactly the same specification that we would put into a natural gas application. So ready for blending, ready for full H2. Few deployments in the US, they tend to prefer the globe style arrangement, and sometimes we'll partner and put other people's pilot valves on there if there's an end user preference for doing that. So yeah, it all depends on the requirements of the market. And again, these are just a few ones on the mainly in Latin America, because my focus is the Americas, so my presentation's a bit more Americas leaning. So we've got hundreds of valves installed in Mexico. Very strong partner there that deploys them a lot, and we're kind of growing. So yeah, we'll see these two stream configurations of the regulators in that worker monitor style arrangement. But yeah, that's kind of it from me. So happy to take more questions on the regulators or go back to questions on the actuated valve. Open book, happy to answer anything.
Awesome. Thank you very much, Chris. That was very informative. Give people a couple seconds here to type any questions they have in the Q&A box there. But if not, Sam, just want maybe a bit of a
I
recap.
yeah, I had one question myself on the first valve. Could you explain to me again how the design reduces damaging flow characteristics like cavitation in the middle of the pipe? I don't know, went above
Sure.
my head.
Let's get back. So, sorry, I'll get there.
Mhm.
So, because we're throttling right at the outlets of the valve, so see flow's coming in, going around, and then being throttled at that outlet. So, say if you're worried about something like erosion, erosion's a function of impact velocity and impact angle. So, you need to be turning the flow. Our main valve body design here doesn't really turn the flow that much. So there's not really a big area like you get on a globe. There's not really a big area where you're turning the flow, turning it back. So those sort of risk areas aren't present geometrically on this product. Similarly with, so say cavitation. So cavitation is induced by the pressure drop itself. So it all comes down to wherever you're throttling the pressure, that's where your cavitation bubbles will form. Cavitation damage happens when those bubbles implode somewhere. So normally in a valve, you'd throttle somewhere in the middle, your bubbles implode somewhere in the middle, and you'd cause damage. We're throttling right on the outlet. So if bubbles are formed, they would be going into the center of the downstream pipe and not just imploding in the center of the flow. They wouldn't be damaging any valve parts there. So yeah, just by nature of the flow path, we're kind of protecting the valve, as it were.
Okay, cool. Thanks.
And Chris, a question had come up before, but on the slurry
Yeah,
handling abilities, I guess with the valve design, what we do is we would be able to harden the
yeah,
outlet, the body, the trim line.
exactly. Yeah, so we obviously choose materials appropriately, harden the key surfaces that we're looking at. We put in we'd be looking at, so say for example on the ceiling configuration, I'd be looking at lip seals that have got the scraper profile on them to scrape any debris away. So yeah, no, I think this is very well suited for dirty service because you've not got those stagnant areas anymore. It's kind of just going straight through the valve, as I just said. So yeah, we're looking at kind of harsher applications with a number of end users because they're getting fed up of replacing valve parts due to erosion and damage.
Fair enough. Perfect. Okay.
Nice. I don't see any other questions coming in. Just a reminder, I can provide certificates of attendance for ongoing training, so happy to do that. I'll send out a recording of this and some follow-up materials next day or so. So look for that. Yeah, that's all on my end.
Yeah. And if you guys, if there's any other questions that people want to take offline, please feel free to reply back to Sam, and we'll be happy to connect offline. But otherwise, Dr. Chris Cannell, thank you so much for all your information. That was fantastic, and yeah, we're looking forward to working closely with you guys and any more customers out there.
Thanks, everyone.
Okay. Talk
Thanks a
soon.
lot.
Bye,
Bye.
everyone.